Sorry about the last video that I heard that the audio is not high enough. I have fixed the problem. Now, what is the consistency of linear systems of equations? This tells us what type of solutions do we have, right? First, we are going to look at the unique set of solutions. Next, we are going to look at infinite set of solutions. Then we are going to look at the solution does not exist, right? We are going to look at these three cases when we look at the consistency of the solution. Now, some of you can ask me, how does this look like graphically? Now, this thing, it's very easy if you're going to visualize it graphically, because it's going to help you to understand more on what you are going to deal with. Right, let us look at the first thing. When we have a unique set of solution, it's when we have two straight lines and those straight lines meet at a particular point, right? When we have two straight lines that meet at a particular point, we are going to say that we have a unique set of solutions, right? When we have infinite set of solution, what do we mean? We mean that we have a straight line which is on top of another straight line. So if we have a straight line on top of another straight line, we have an infinite set of solutions. And if you have a line, if you have two parallel lines, let us say these lines are parallel. If you have two parallel lines, we will deduce that we have an infinite number of solutions, right? So how can we do it? Now, how can we say, because we are going to have a system of equations. We are not going to have equations which are going to be two variable or three variable, but we are going to have equations which have more variables in them. Now we have two methods to see that we have these types of solutions. We have two methods. The first one, it's the Gaussian elimination. The first one is the Gaussian elimination, and the second one is going to be the rank method. Now, if you look at the Gaussian elimination, and you have this case 1 0 0 3 4 3 1 0 8 5 1 5 3 2. If you have this case where the last row is in that order, we say we have a unique set of solution. If you have our last row as that format, we will say that we have a unique set of solution. What does it mean really? It means that z is equals to 2, and your second row, it means that y plus 5z is equals to 3. We can take this z, substitute it back there, we will get our value of y. And our first row, it's x plus 3y plus 8z is equals to 5. We'll get the z that you got here, we'll get the y that you got here, we'll find our value of x. Can you notice that for each value of for the value of z that you substituted to this equation, you are going to get a particular value of y. And if you take this particular value of x, substituting it to this equation, and take this particular value of y, substituting it to this equation, you are going to get a particular value of x. Because we have this condition, we will say we have a unique set of solution, right? Let us look at another statement. 1 0 0 3 1 0 8 5 0 530. Right, because our last row is in that order, we will just say we have infinite set of solutions, because our last row is in that format. Because our last row corresponds with a particular variable, we say here z is equals to alpha. We let z is equals to alpha to bring us a free variable to solve for the other variables that you saw here, right? And then the last condition, it is 1 0 0 3 1 0 8 5 0 5 3 2. Because our last row is in this particular order, we will say that we have solution does not exist. Because the solution does not exist, why do we say so? We say because we can see that 0x plus 0y plus 0z can actually give us 2. Not 3, give us 2. Because we have this, that thing is false. You cannot add 3 zeros and get 2, right? And you cannot add 3 zeros and get a number or a whole number, or a natural number, sorry, or an integer. So always make sure you understand this concept for a Gaussian elimination, that for a unique set of solution, we're always going to have a Gaussian elimination in that order. For an infinite solution, we are going to have a Gaussian elimination in that order. And for the solution that does not exist, we have a Gaussian elimination in that particular order. But we are going to focus mainly on the rank method. We are going to focus this thing on the rank method. Now, some of you may ask me, what is going to be the question look like? How is the question going to look like in an exam? I'm just going to show you now. It is how your question is going to look like in a particular exam. This is your question. All right, that is your question, and make sure that you understand it. That is how your question is going to look like in your exam. And please take note and write it down. Right, take the note and write it down. Right. So it says, determine if the systems of equation has a unique solution, no solution, or infinitely many solution. You must show all workings do not solve the system of equation. This is going to be the question on your test or an exam or a major test. So how can you say this is a unique solution and no solution or an infinite number of solutions? Right, how do you see? For the rank, not for the rank, let us start here. For a given system of equation below, right? I'm going to give you a system of equations now. If I say it's ax1 plus bx2 plus 3, it's actually going to be c. cx3 is equals to k px1 plus qx2 plus tx3 is equals to z, and then nx1 plus mx2 plus ss3 is equals to v. Now, for a given system of equation, how can you answer this type of question? Very easy. First thing that you need to do, you need to write this system as an augmented matrix. First, you write AX is equals to B. You need to write it as an augmented matrix. Write it as AX is equals to B. Now this is how we are going to write it, right? We are going to take out the coefficients. Another thing that you need to take note is that this column is for x1, this column is for x2, this column is for x3. If the equation was written in an order which is not readable, always rearrange your equation in this format. Your first column is x1, your second column is for x2, your third column is for x3 or xyz column. Right, so I'm going to take out the coefficients of the following variables. I'm going to have a, p, n, p, q, m, c, t, s. Draw a line. Drawing a line, I'm going to include those answers there. This is an augmented matrix. For a given augmented matrix, you need to take out matrix A. I'm going to take out matrix A. Matrix A, it's this particular matrix, that particular matrix. So that is matrix A. Matrix A is going to be A, P, N, B, Q, M, C, T, S. That is matrix A. And then we need to take out matrix AB. Very crucial matrix. What is matrix AB really? Matrix AB, it's this matrix without that line. That is matrix AB. Right? So matrix AB, it's going to be now A, P, N, B, Q, M, C, T, S, K, Z, V. That is matrix AB. Right. Now, if you can take note, matrix A is in matrix AB. Always note that matrix A is on matrix AB. Now, how can we say we have a system of equation which has a unique solution? We have a system of equation that has an infinite solution. We have a system of equation that has what is this? What is this? We have do not exist. If you have this condition, if you have rank A is equals to the rank of AB and is equals to n, you will say here we have a unique set of solutions, right? And if you have rank A, which is equals to rank AB, but now it's going to be less than n, we are going to have an infinite number of solutions, really. And then if you have rank of A less than the rank of AB, here we have a do not exist. Right. Some of you will say, what is n? N is the number of the given equations. It's the number of the given equations. Right. So this is what you need to do whenever we say or whenever we ask you this question here. So we expect you to find matrix. We expect you to write it in this form. Take out matrix A, take out matrix AB, and find the rank of A and AB. Just remember that the rank is the number of linearly independent rows or columns in a matrix. So in a given matrix, A rank is the number of linearly independent rows or columns, which means are those columns or rows which are linearly independent. They are totally different from one another. We will say that we have that is a rank. Right. Let us look at this example. Sorry about that. I needed to publish this video as quick as possible. All right, let us look at this example here. I want you to write it down, but I don't see it. Okay, this is the example. Finally found it. It says x1 plus x2 plus x3 is equals to 2 minus x1 plus 2x3 plus 3x2 is equals to 8, and 4x1 minus 4 is equals to minus x2. And we need to answer this question here. We need to answer this question here. Right. So to answer that question, first of all, we need to check that our system is writing in x1, x2, x3 order. So we have x1 minus x1, 4x1 plus x2 plus 3x2 minus plus x2 plus x3 plus 2x3 this is equals to 2 is equals to 8. This is equals to minus 4. So because we have written in this order, now we can just say, now we can write this equation as ax is equals to what? Is equals to b. We need to write an augmented matrix of that. It's going to be 1 minus 1, 4, 1, 3, 1, 1, 2, 0. Why we substitute 0 there? Because x3 is not present, so it's 0, and then 2, 8 minus 4. Right. So that is our augmented matrix. The next thing that you need to do, we need to take out matrix A. Matrix A, remember, it's this matrix. Matrix A, it's 1 minus 1, 4. 1, 3, 1, and 1, 2, 0. And then we need to take out matrix AB. Matrix AB, remember, it's this whole entire matrix without this line. So it's 1 minus 1, 4, 1, 3, 1, 1, 2, 0, 2, 8, minus 4. That is matrix AB. Then the next thing that we need to do, we need to find the determinant of this matrix of A. So the determinant of matrix A, remember, you can use any row or any column that you're going to prefer to find the determinant, or you can use a calculator. But make sure that when you're writing an exam, you show this step. You can use any row or any column. So if you use the last row, I'm going to have a 4, 1, 1, 3, 2, minus 1. If you use the last row, minus 1, 1, minus 1, 1, and 2. So what is the determinant of this matrix? 4 minus 4 times 2 minus 3 minus 1 times 2 plus 1. Your answer is going to be minus 7. So that is going to be the determinant of A. Can you please try it? It's also try it also. Some of you can use this row, can use the first row on A, use that row. It does not matter, but always use a row or a column that has most 0 in it. So if you use the first row, I'm going to have a determinant of 3, 2, 1, 0, minus 1, minus 1, 2, 4, 0, plus 1, minus 1, 3, 4, 1. So if you use the last row, or the first row to calculate the determinant, it's still fine, right? So it's your answer again, it's still minus 7, right? Because we found a determinant here which is equals to a number, we will say that the rank of A is equals to what? Is equals to 3, because we have 3 rows which are linearly independent of one another in matrix A. How can we say that? Because our determinant was not equals to 0. If our determinant in A was equals to 0, it means there is a row or rows which are linearly dependent to one another, right? So we get that. Then the next thing that you need to do, we need to find a matrix in AB. That will give us a number. The trick is, remember I told you that matrix A is found in matrix AB. To be safe, use the same matrix A and find the determinant. Remember, in rank we are interested on the type of matrices that can give us a determinant of a number, not of a determinant that will give us a 0. So use the same matrix. Now call it AB1. So matrix AB1, it's 1 minus 1, 4, 1, 3, 1, 1, 2, 0. And find the matrix of AB1. So the determinant of AB1 is going to be, use any row or any column, it does not matter. I use any column or a row that does not matter really. 1, 1, 4, 1. Your answer still here is still minus 7. Because our matrix AB1 has a determinant of -7. Ask yourself, where is matrix AB1 allocated? Matrix AB1 is allocated in matrix AB. So the rank of matrix AB is equals to 3. So now we can conclude. How many equations do we have? We have 3 equations. So n is equals to 3. Right. Because n is equals to 3, we are going to say the rank of A is equals to the rank of AB is equals to n, is equals to what? To 3. Because all of the rank of A and the rank of AB and the number of equations are also 3, here we have a unique set of solutions. Right, we have a unique set of solutions. Right. Let us look at another example. Right, let us look at another example. The question is still the same. It's still the same question. Nothing has changed. The question is still the same. But now we have an equation like this one. Now we have equations like 2x, not 2x1, it's 2x minus 2y minus 4y to 4z. 4z is equals to minus 2, right? And then we have 3x minus 3y minus 6z is equals to minus 3, and minus 2x plus 3y plus z is equals to 7. The question the question is the same still. It says determine if the following systems of equation has a unique solution, no solution, infinitely many solution. You must show all workings do not solve the equation. So we are going to apply that question here. What is the first thing that you need to do? You need to write the system of equation as augmented matrix. So I'm going to say first AX is equals to B. Then an augmented matrix will be something like this. 2, 3 minus 2, minus 2, minus 3, 3, minus 4, minus 6, 1, negative 2, negative 3, 7. So I've written an augmented matrix. The next thing that you need to do, you need to take out matrix A. Matrix A, it's going to be 2, 3 minus 2, minus 2 minus 3, 3, minus 4 minus 6, 1. That is matrix A. And then we need to take out matrix AB, right? Matrix AB, it is 2, 3 minus 2, minus 2 minus 3, 3, minus 4 minus 6, 1, and then minus 2 minus 3, 7. Right, that is matrix AB after all. Then remember, the trick is we need to follow this. We need to find the rank of A, rank of AB, rank of A, rank of AB, rank of A, rank of AB. This question always revolve around the same thing. Matrix A, the rank A minus rank AB. Right. So let us find the rank of A. So first of all, we need to find the determinant of A. So find the determinant of A. We are going to say the det of A is equals to 2 minus 3 minus 6, 3 and 1 plus 2, 3, negative 2, negative 6 and 1 minus 4, 3 minus 3, negative 2, 3. So if you calculate the determinant, can you please do that very quick? 2 minus 2 minus 4, 3 minus 3, negative 6, negative 2, 3 and 1. Your determinant of this matrix is 0. Now, this is new. This is new. Now, what do you do when your determinant of this matrix is 0? We always say the same thing. The rank of matrix A is actually going to be 2. Why I'm saying it's going to be 2? Because there is a row there or a column that is linearly dependent to another row. So that's why we'll say that the rank of A is going to be less than the order of the matrix. I think this thing is very clear. Or how can we say that the rank of A is 2? We need to find a sub-determinant in A that cannot give us a determinant of 0. Any sub-determinant in A that cannot give us 0. For example, this determinant here cannot give you 0. This determinant here cannot also give you 0. So I'm just going to pick this one. So I'm going to call it now A1. A1, take it out, negative 3, 3, minus 6, 1. And find the determinant of A1. What is the determinant of A1? Negative 3 times 1 minus 6 times 3. Now, if you calculate that, I'm going to have minus 3 plus 18. Your answer is going to be 15. Right, it's going to be 15. Because a determinant in A, because a matrix in A that gave us a determinant of 15 was found in A and its order is a 2 by 2 matrix, the rank of A, it's automatically going to be what? Going to be 2. Right, it's going to be 2. Right, so that the rank of A is going to be 2. Right, let us look at the rank of AB. Now, I'm just going to tell you this. You can try these combinations. Let us find AB. For AB, I'm not going to do everything. But can you please try this for me? And confirm, doesn't matter, and confirm that all of these determinants can give you 0. This is C1. This is C1, C2, C3, C4. Right. If you try these combination of determinants, they will give you 0. If you find the determinant of a matrix of C1, C2, C3, your determinant is going to be 0. If you try a matrix of the determinant C1, C2, C4, again your determinant is going to be 0. If you try a matrix of the determinant of column 1, column 3, column 4, again the determinant is going to be 0. If you find the determinant of this matrix column 2, column 3, column 4, again your determinant is going to be 0. But I'm going to pick this determinant and lay it out. I'm just going to call it AB1. What is AB1? It's going to be C2, which is -2, -3, and 3. C4, it's C3, which is -4, -6, 1, and -2, -3, and 7. If you find the determinant of this matrix, it's going to be 0 automatically. But what you can actually do, you can just find a matrix, a sub-matrix here that can give you a number. I'll try that one. So the determinant of AB1, it's going to be -6 times 7 minus 1 times -3. So if you try it, -6 times 7 minus 1 time plus 3, your answer is going to be -39. So we can just conclude here that the rank of AB, it's also 2, because you know the definition why. And then now we can conclude. How can we conclude? We will just say the rank of A is equals to the rank of AB, and this thing is less than n. Remember, n, it's the number of equations. N here, how many equations do we have? We have 3 equations, which is going to be what? It's going to be 3. So in this case, we have something which is called an infinite number of solutions. Right, an infinite number of solutions. Right, I think you are going to be good on that one. Right. For homework, I want you to try this one. 2x1 minus 4x2 minus x3 is equals to -8. And then we are going to have 3x3 plus 4x1 minus 8x2 is equals to 4. And then here I'm going to have a 4x2 minus or plus x3 minus 2x1 is equals to 11. Can you please try this thing on your own and tell me what type of solutions do you have in a comment section? If there is any questions that you find it tricky, can you please also refer to the video that does not have any audio and look at the procedure. Just look at the procedure. How do I do the problems? And then if you have any question, touch me in class or leave your question in the comment section. Bye.